This frisbee reacts differently to different types of radiation. As you can see, artificial visible light has no physically discernible effect on it. However, once we use an ultraviolet light, the frisbee will change colors. The longer the material is exposed to UV light, the darker it becomes. Eventually, these colors fade away, and the frisbee is left at the color that it started with. This frisbee is photochromic. With enough energy, the bonds between atoms rearrange, changing the structure from colorless to color. This physical change in structure is known as photoisomerization. Lower energy radiation is called non-ionizing radiation. That is, this radiation does not contain enough energy to excite electrons into leaving atoms. Artificial light is non-ionizing, which is why it has no effect on the frisbee. On the other hand, ionizing radiation, including UV rays, gamma rays, X-rays, and particle radiation from radioactive decay, is higher energy. When exposed to ultraviolet light, a kind of ionizing radiation, the frisbee will be photoisomerized. Both non-ionizing and ionizing radiation are found in our everyday lives, and both have consequences on our health. Ionizing radiation occurs naturally. Radionuclides such as radon are found in soil, water, and air. The effects of ionizing radiation are well documented. In high doses, ionizing radiation can impair the functioning of tissues and organs, and can cause hair loss, radiation burns, and acute radiation syndrome. At a low dose rate over an extended period of time, ionizing radiation can lead to cancer. Non-ionizing radiation can be found in radio frequency waves used in many communication applications, in microwaves used in kitchens, and in infrared radiation used in heat lamps. Non-ionizing radiation has an impact on our health as well. Our cell phones release radio frequency waves, which can lead to cancer. Direct exposure of this kind of radiation to the brain, eyes, genitals, stomach, liver, or kidneys can be dangerous. The government uses SAR, or specific absorption rate, to measure radiation. The iPhone 7 has an SAR of 1.14 watts per kilogram on the body, 1.1 watts per kilogram at the head, and 1.16 watts per kilogram using hotspot or AirDrop. The Samsung Galaxy S9, on the other hand, has an SAR of 0.96 watts per kilogram on the body, 0.35 watts per kilogram at the head, and 0.95 watts per kilogram using hotspot. Although research isn't conclusive, it's probably safest to stay off your phone as much as possible.